So the today, first of all, good evening, all of you. And today, the method which we are going to discuss is predictor corrector method. Okay. And before starting, in this, we will use a different way. We also use Rankata method, Euler modified. Okay. And there are some methods which are based on Euler Rankata method for predictor corrector, and then after we will discuss about Millis predictor corrector method. Okay, so first I would like to share my screen, and then after we will discuss all these one by one. Yes, so this is my desktop screen, and I hope that you can see this book, which is Numerical Methods, written by B.S. Grewal. This is my metal window, and this is also the predictor corrector method using Euler method. Okay, which we need usually to write metal programming. Okay, so for that we need to convert all type of methods in the form of iteration. Okay, so usually when we apply numerical approach to find out the solutions of any kind of equation, whether it is a system of equations or differential equations. Okay, we need iterations. So the method which we are going to discuss is predictor corrector, and very interesting and simple to use. Just we need how these methods are used, and how this will work. Okay, so this is very simple, which we are going to discuss now. Predictor corrector method, and for that we have, if we have xi minus 1 to xi are two consecutive mesh point, when you have the interval from this point to this one, and usually this is the x naught and this is xn, and we divide in this way. Okay, we have any, this is xi, and this point is xi plus 1. Okay, or this point is xi minus 1. Okay, so when we have any two consecutive point, in that case, we have yi is equal to yi minus 1 is equal plus hf x naught plus I minus 1 h yi minus 1. Okay, this is by Euler method, which we have discussed already. And after that, we applied modified Euler method, and in the form of iteration, we have this equation. So what is the purpose of this equation? We get the value at the point xi minus 1 and yi minus 1, and we have the value on the next point. Okay, yi. Okay, so this value will be used in the second equation. This is equation number 2. This number 2 is missing at this place here. Okay, and corresponding to xi, then we and this is fi minus 1, yi minus 1. Okay, so this is, we have a new modified value, and this approach is this technique of refining an initially crude estimate of yi by the means of more accurate formula, since the formula which is represented in 2 is more accurate. Okay, and provide us updated value. So this type of technique and method is known as predictor and corrector method. This is one thing, and we will use this approach also. Then first we discuss this technique. So what we do, first we need to convert all these equations are already in iteration format. Okay, so we can directly use these equations in MATLAB. See, here is MATLAB window, and first I have to close this file. I have to open, yeah, this one. So here I prepared 3 different examples, and I would like to open this one, this file, and this file. Okay, the file number 3 and file number 2 both are similar. In both the cases we have Euler modified method, and in this also modified. Okay, And when you will scroll down, we are coming at the place of the formula where we apply. So the equations which we just now saw in the PDF file here, the first equation is used for predictor, and the second equation which we discuss here is used for corrector. Okay, and when you will convert these equations, you can see this is the equation number one. This is the equation number one. Okay, and corresponding to that, we convert the same equation in the form of MATLAB syntax. Okay, and this is the second number equation. Here is the equation number two. Okay, so here you can see these values, the syntax corresponding to that, and this is the predictor value. Okay, this value will pass at this place corresponding to I plus 1. So here the thing is I minus 1 or I plus 1 doesn't matter. The thing is we are doing index at this place. See, our index is starting from I. Okay. So I equal to 1. I equal to 1 to up to this one. Either you can start from 0, but if you will start from 0, I equal to 0 to then you have to change entire accordingly. So usually we start initialization from the initial condition, and we always put the index is 1. Okay, so that when you will write the program, there will be some similarity, avoiding any kind of confusions. Okay, so the main objective is just to convert these two equations, which you can see in equation number 1 and 2. Okay, so this equation is the same as we are using in MATLAB. You can see this one. Just the MATLAB syntax are there. So the Euler method is used for the predictor, and this value will be computed. Then this value will be used at this place. You can see in the second equation. Okay, so in this way we will use we need to convert these two equations, equation number 1 and equation number 2. Okay, and the syntax are very simple. I think there is no more doubt in these two equations. Only these two equations we replace in the other methods which we use. Okay, and the other syntax and statement which we required for the differential equations and initial values, these are similar. There is no difference. So in this script file, I explain everything which we are discussing now. And here we are choosing the example y dash is equal to minus 2y plus 1, and this is the initial condition y0 is equal to 1. First, we need to define the function, and we are using anonymous function at this place. Just you need to convert this equation in MATLAB syntax using anonymous function. So f is equal to @ty minus 2y plus 1, and then after we need the initial condition. Okay, and then t span, the interval, in which interval we want to compute the value by using the same method. Okay, so here we are choosing the t span is 0 to 5. Okay, 0 is the initial point, and at 0 we are given the value y. Okay, and this is the end point or last point of the interval. Step size we can manipulate according to our desire. Okay, but we are choosing at this place h is equal to 0.1. So you can see these sequence of statement which we are using at this place are same as we discussed the other methods previously. Then after, you can come to at this place where we want to store the initial arrays. Okay, and you know the length of each must be same corresponding to t values and y values, both must be same. So what you can do at space, you can see t values which you are seeing at this place, t values are equal to t span 1. Okay, t span 1 is this value. Okay, this is t span 1 and this is t span 2, first value and last value of the interval. Okay, and h is the step size. So when you will execute this statement, we have an array of t values corresponding to this interval and the step size. And the length of t values and y values must be equal. So corresponding to t values, we have to generate y array of zero vectors. So many times we already use this statement. Okay, zeros in all the element of y value will be zero. Then after we need to update all the values after computing uh, using the formula which we discussed below. Okay, and we will initialize by giving the indexing of initial value. Okay, so the first value y value 1 is index corresponding to first value of t. Okay, so this is the first value of y and corresponding to t0. Okay, so now first we will use at this place we are using predictor corrector method with Euler modified. So you can see this is the predictor value as we already discussed. Okay, so corresponding to this loop which we are using at this place, I equal to 1, 2, 3, 4, and so on. Also, you can break all these two equations by putting I equal to 1, then you will have two equations, then you will choose I equal to 2, and so on. Okay, as I explained in the previous older lectures, how you can break all these. Okay, you need to operation and critically understand how these will work, and this will be possible when you will put I equal to 1 on the right hand side and check this value. Okay, you will get y2. Y2 means y1 because here these are the index. So when you will execute this file and at the end you can see these are the statement to plot the graph when you will solve this example, and you see that all the statements are we are using in the same file. We are not using in this file user defined function. If you need to use user defined function, you can do, because in the previous lectures we discussed all the methods by using user defined functions, but here we are not doing such a way. Okay, so just in the single file we have everything, and when you will execute this section, we divide this file in two parts. In the first part we have description about the method, but in the at this place we have the example. When you will execute this section, and you will see that we have the corresponding plot of the solution of the given differential equation using predictor corrector method with Euler modified. Okay, so you can see the corresponding graph. Okay, so the process is very quite simple. If there is any doubt in this file, please let me know. If this is clear, then the other approach which we will use for this predictor corrector, only smaller change will be there. So please let me know if there is any question for this discussion, so that we can go ahead. Yes, please, if you have any doubt. Any question? Is it clear? No question. Thank you. Okay. Either you can unmute your mic also, no problem. So this was the second example. And the third example, there is no big difference. All the statements are parallel to those which we discussed there. Only some small syntax are changes in the place of I. We are using, I think, n in this file. Yes, only n is there. Okay, so rest this formula is the same as we discussed in the second example. So not required to discuss this file. And when you will execute, you will have the graph of the solution. Okay, on the vertical line you have the approximation of y, and on the horizontal line we have time space. Okay, and also we have approximation at t equal to 2, we have this value. When we have t is equal to, the value of y is this one. Okay, So you can see display final approximation by using this statement. This also we will discuss in more detail. Okay. Now come to the first example. Yes. So here what we are doing in this method, predictor corrector. Just 1 minute, I have to scroll down. Yes, you can see in this example, for the predictor step, we are using Euler method. But for the corrector, we are using fourth order Rankata method. Okay, and as you know, in the very first, second, third lecture, when we start numerical methods and corresponding to Euler, Rankata method is more fast and provide us more accurate values. Okay, so for the predictor, we used at the place Euler, and for the corrector, we are using Rankata. Okay, so these are the same equations which we discuss in the Rankta method, and this is the same equation for the Euler method. Okay, but the Euler is used at this place for predictor, and this is for corrector. Rest all the statement input values, these always will be remain same in all the methods. Okay, just these equations will change. Only these equations we need to change. And to make these changes, first try to convert all the methods in the form of iteration. And when you are able to convert, then this will help you to write MATLAB programming. So you must try yourself without seeing this MATLAB code. If there is some kind of error, then check your code and compare where is the error. Okay, once you can take the help from the codes which we have prepared at the place. But if you will do your own self, this will also help you for more understanding. Okay, so in the beginning we need help, how we can write the program, how we can manipulate them. Okay, syntax are very important. Sometimes a single dot can create a file and our program will not run. So everything step by step we need to clear how you can check the error, how you can write the program, how you can plot the graph, and many more things are there. Okay, so I think in these three methods, when you will execute, and you can see, yes. So here we are comparing both the results also. You can see at the top, we on the right side, predictor, the graph in blue color, we have based on Euler. Okay, and also the same method is used for corrector. And after applying the corrector method, the values which we calculate in Euler method also used in RK4, and you can compare the difference between these two graphically. Okay, at 0.6 there is more difference. So the graph which is in red color is more accurate as compared to predictor method. Okay, so you can compare all the graphs, all the results in the same graph. So this is graphical comparison of the two methods. Okay, and when you will see the code, you can see this is the first method by using Euler. Okay, and this is the plot corresponding to second method, corrector. Okay, we want to compare these two results also. Similarly, you can use this approach in this file, in this file. Okay, you can do. So I hope you will try uh, comparison of both the result, predictor and corrector in these files, this method. Okay, and also you can choose some more different examples by replacing these equations. Okay, so this is also the simple approach without using user-defined function in the same file. In during the previous lecture, one was asking we can create a single file without using user-defined. So this is the example you can do in this way also. Now, is it clear? Any question, please? Any question, please? Okay. If you are not open your mic, I suppose that it is clear. Now we have, okay, this is also input function we can use. We will do later. First, see the Milne's predictor method. I put at this place two examples. Okay. There are two examples. So before discussing this method, we have to open this file. So here is just 1 minute. I have to close. Okay, just 1 minute, please. I have to open the method. This is Rankata, Predictor Corrector. Yes. So from this place, the Milne's method, we will not discuss more about derivation of the method, but we need how we can use. Okay. So here you can see, go through the detail how you can establish this formula. Okay. But for our purpose, you can see at the place F naught, F1, F2, F3, these values we need to compute. We need to compute these values, which you can see. Okay, and also you can use uh, you can use the address space y1, y2, y3 to compute value. The Rankata method can be also used. You can use Euler method also, because we are given only the initial value, and we need four step. Okay, one is initial, and then y1, y2, and y3, and corresponding to these we need to calculate f naught, F1, F2, and F3. Okay, and then after we are able to write the formula, and you can see these two equations. So this is the predictor and this is the corrector. Okay, so these two equations are important. And you can see that here is y4 and y4. Then after we have, this is the predictor y4 and this is the corrector, which will be the more accurate. Okay. And then after, in the same way, you can get the value of y5 corrector, predictor, and then corrector. But the most important thing is that which we need, which we require to write the program, that is in iteration format. Okay, and for the same, you have to come back at this place. Epic pen. Yes. So here you can see. Here is the equations which you can see in 1.2.1. Okay, this is based on the Euler method, and this is the corrector. Okay, which we use in the MATLAB. But here for the Milne predictor corrector, you can see. So this is the given differential equation. Okay, this is the given differential equation with the initial conditions ya is equal to y naught. Okay, and then the equations which we use for predictor corrector. Okay, and here you can see, we need to compute y1, y2, y3. Y naught you are given the initial condition corresponding to x is equal to 0. Okay, but we need to compute y1, y2, y3. You can use Rankata fourth order. We can use Euler method. Okay, or other method, whatever you use, but we need to compute these values. After that, the iteration format of the predictor formula for Milne. This is the yi minus 3 plus 4h upon 3, 2f ti minus 2 yi minus 2 minus f ti minus 1 yi minus 1 plus 2f ti yi. Okay, and this is the corrector step. So the value which we compute at this place will be used, you can see here. Okay, and this is the fti minus 2, yi minus 2, then we have 4 fti minus 1, yi minus 1, and h by 3, yi minus 1. So this is the corrector value. But after that, we need to update the value of y. So this value is again used at this place. Okay, so this is the final value of yi plus 1. Okay, so these equations are required to write MATLAB code. Okay, these syntax are important. So the most important thing which I always say, you need to convert the given solution or the equations in iteration format, and these are very quite simple. Okay, you can again check from, yes, you can check from this place. Okay, so these equations are converted and you can easily do in this format. So once you have these equations, now this equation will help you to write MATLAB code in very easiest way. Come back in the MATLAB, and here when we will open, yes, so here this is the Euler method, and there is nothing but you can see the equation. This is the formula. This is the formula of Euler method. Okay, yi plus 1 is equal to yi plus h f t y. Okay, ti yi. So when you will put at this place I is equal to 1, when you will have y is equal to 1, what will be there? So when you will use, yes, so when you will use in this equation I is equal to 1, so this equation will be in this form: y2 is equal to y1 plus h f, then we have, sorry, this is t1. Okay, this is t1, here is t1 and comma y1. Okay, so this is y naught, this is y naught, and this is t naught, and this is again y naught. Okay, and this is y1. Here we are using index. The values of I are index. Okay, so you can easily compare this syntax in the MATLAB. And once it is clear, you will enjoy the MATLAB code. Now come back in the Milne predictor corrector, and the arguments you can see argument for Euler method and that of R are same, f a b y naught n. Okay, so now what we do at this place, first we need predictor and corrector. See at the place, see these equations very carefully. What are there? yi minus 3 plus 4 h by 3 2 f t I yi minus f t I minus 1 yi minus 1, then plus 2 f t I minus 2 yi minus 2, and same you can compare here in the predictor. You can see in the predictor this equation is the same as in the MATLAB at this place. Okay, and the next equation which you can see here, corrector step using Milne method, is the same as, okay, so at this place we are using predictor and corrector. Okay, and the values which we need, y1, y2, y3, which will be used at this place. Okay, first four values we are required. One is the initial condition which we will be always given. Then on the basis of initial condition, we will compute y1, y2, y3. How you can do? C at space. So here we are using h is equal to b minus a upon n. This is the step size, and t is equal to ahb. This value will be computed on the basis of n. Okay, and at the initialize y using the single step method, which is using Euler method. You can use other also. Okay, but here we are using Euler method. So here these are the step. You can see f a, then a plus 3h and y naught. Okay, and three values will be computed. Three means three values will be computed by using this formula, and all these values will be stored in the left hand side. Okay, but we need index. For the indexing, what we do, we need to store all the values corresponding to x1, x2 and x3. Okay, so we will generate here zero vector, and see here the values which are stored at this place, and will be calculated at this place, and that will be indexed at this place. Index is from 1 to 4. Okay, y1, y2, y3, y4. So there will be four values which will be stored at this place. Okay, for Euler method by using. Then when we will able to compute these values will be used for the predictor mainly method and corrector mainly method. Okay. So you can see now we are starting the for loop from 4. This is the reason because first three values already computed at this place. And when you will use this loop for I is equal to 4 to n, then the other values which we need to compute in the given interval automatically will be computed and will be stored at this place. Okay, so this is the complete Milne predictor corrector. But to compute y1, y2, y3, we need to use, you can use Euler method, you can use Rankata, or you can use other method. Okay, so now see the results. Here is the example where we are using to compute the solution of this differential equation. We are using here user defined function, sorry, anonymous function. Okay, so f is equal to, we have at the rate ty minus y product t, and these are the initial conditions. A equal to 0, b is equal to, this is the interval from 0 to 2, and initial condition is 1, and that of value of n is 100, which are the number of steps. So everything I have described at this place. And now we are calling the function, and the same which we assign, and the order of the argument must be same. Okay, so you can copy and paste here. But the values which you will compute will be t and y, because when you are going to plot the graph, okay, so we need both the arrays t and y, values of independent parameter, independent variable t, and the dependent function y. So that's why we are using t and y, and corresponding to each index, the value of t and y will be stored in the variable, assignment variable t and y. Okay, then after you can easily plot the graph. So these are the statement to plot the graph. Okay, so plot function is there, this t independent, y dependent, x label, y label, then title, grid on, and when you will execute this sequence of statement, you can see wonderful graph is there. Okay, so in this way you can use predictor and corrector. There are several methods. Okay, you can easily write the program and you can execute. So there is one more example, but I will recommend you, you must try yourself this example. Script is there. Okay, so here we write a script mainly predictor corrector, and also we are using in this example only, you can see here, fourth order Rankata method for the compute initial values. Okay, and this is the predictor, and then after we have the corrector. You can see there was three equations in this file. Okay, this is the predictor. Then in the corrector step we have two more equations. Okay, so now this code which I am showing you, this is the absolutely same as we have the equations in this file. Okay, but the first example which I present for you, we were using only this equation. So you can update the values by using this more equation. Okay, and here in the MATLAB code also, first these are the values for the predictor, these are the values for the corrector, and this will compute, will update all the values for yi plus 1. Okay, and to get the value of initial values for this formula, we are computing k1, k2, k3, and yi plus 1. So first these values will be computed. These will be used for the predictor, and the values which are computed in the predictor again will be used at this place, and all these values after computing will pass through this equation. Okay, And one more thing, when you are writing the MATLAB program and the same steps which we have in the method, so always follow the steps which are used in the formula in the same order. Okay, those sequence of the statement will be corresponding to all these equations and formulas. And now you can come back. And when you will execute here, we are executing the statement. And when you will execute, you can see the same graph at this place. Okay. And if you want to add grids, just enter grid on, and the grid also will be inserted. Yes. Okay. So if you need more changes in the graph, you can do according your choice by adding markers, colors, etc. Okay. So all these things has been discussed in the very first lecture, but here uh, uh, main important thing is how we can write the program for different methods and how you can implement the formulas which are available in the numerical methods which are available. Okay, and how you can easily convert them in the MATLAB syntax by using some sequence of statement, and how you can define user defined functions also, and how you can plot them. So everything related to uh, this predictor corrector we have discussed. And if still you need more study, convergence, then stability, then how to calculate the time, you can calculate the time also. Okay, I will try to include how you can calculate time for each method. There is only one statement you will use. I will include in the coming sessions. Okay, I think the method which we discuss is very clear to all of you. Any question, please?
Yes, sir, it's
Any
clear.
question?
Yes, sir, it's clear,
Yes,
sir.
sir. Clear, sir. No question.
Okay, thank you, thank you.
Welcome, sir. Thank
Now,
you.
one more thing which I want to present for you, and this will help you. Yes, okay, and you can see here we have predictor and corrector Euler method. Okay, so this is nothing new in this, but the thing is this part CLC. So what we do, we make input based. When you will execute this file, and you can see in at this place it is asking give the input. Okay, so you can give the input. Suppose the value of dy upon dt is equal to minus y. Okay, then it is asking enter the initial value of the interval AB. We can choose 0. Okay, then asking the, sorry, this will be the enter the value B, second value. I have to make small change at the place. The second value is 2. Then it is asking about the initial value Y. The value of Y is, you can see at the place 1. I put 1 and then enter. Here the value of n, you can choose accordingly, n equal to 100, 200, whatever you need. Okay, there is some error. Just 1 minute, we can check it. Anything is missing. Index in one position is invalid. Okay, I think there is one value negative. Okay, index must be positive.
Sir, I
Once
think
again, we can check
one
it.
value may be zero.
Pardon?
Not, zero is not allowed in MATLAB. I think there is one value zero. We are taking.
Yeah, I think some value is incorrect. Okay, so the main thing is you can write your program in this way by giving the input function. Okay, you can use also. After correcting this way, I will provide you. So these are the these inputs are we are using for this one, but I think there is some error.
But I think in function predictor corrector Euler method, index starting value maybe
Minus y
in
divided is
function
equal to,
in function.
pardon?
I think in function there should be correction. Predictor corrector function. I think there is some starting value must maybe zero. Therefore, it is providing error in function itself. Line 15. Predictor corrector Euler line 15. Sir, you have opened numerical value. I am saying about predictor corrector Euler method. Function itself. Yes. No, sir.
Just 1
Please
minute.
open predictor corrector. The function.
Function
window. Yes,
predictor corrector.
Yes, sir. Please open this. And in 15 line, there may be some error.
Yes, some error is there.
Yeah.
Error in predictor corrector, line 15.
That's
yi plus 1 is equal to yi plus h. No formula is correct. Here is also no problem. Before using this, I checked, but now I think some error has been created by after saving the file. Index in position 1 is invalid. Array indicate must be a positive integer or logical. Okay. Okay, once again we can try. Okay, after checking this file, I will upload for you. Okay. Yeah. So this is all about today's session, which the methods which we need to discuss. And I hope that all these are very clear to all of you. So tomorrow, what about tomorrow? Can we fix this time? 9 to 10 is fine for all of you. If we can make change in the
I
time.
believe we should fix the normal time, sir.
This time is fine, all of you?
Yes,
No,
sir.
it's not fine. Maybe you should fix 7 tomorrow.
7 Indian Standard Time.
Yes, the former time that we have been using.
Okay.
Yes, sir. That's preferable, sir.
Okay. Thank you.
That's my own suggestion.
Okay, these files will be uploaded after the session, and the PDF file will also be available. You must try all these methods, and also the PDF file I will try to share in the WhatsApp group. But all these content will be available on this platform. Okay, so thank you very much for the today's session, and tomorrow we will join at the same time. Good night, all of you.
Good night, sir. Thank you.